I'm Ken Janda. I'm the Dean of Physical Sciences, the best job in the world as far as I'm concerned. And the reason we're here today is for the dedication of Rowland Hall as a National Historic Chemical Landmark by the American Chemical Society. So thank you for that. We have many guests, and everybody but the ones who might be mentioned would be glad I'm not going to go through the list, except I want to thank Joanne Rowland for coming, Jeff, Taylor, and Lindsay. So the Rowland family supported Sherry, I'm pretty sure, through this historic work that we're all here to celebrate today. And also Mario Molino was, of course, closely involved and named a Nobel laureate. Unfortunately, Mario couldn't be with us today, but he asked everyone to have at least one extra sip of champagne in his honor after the ceremony.
If ever an academic building deserved such recognition, it is this one, for it is here that two brilliant and insightful scientists, Sherry Rowland and Mario Molina, saved the world from catastrophe, right? And I will say that I took it upon myself to look at the ACS website and the other extraordinary places that have been designated as historic landmarks. And there are very many impressive places that have been designated, but not many of them can say that they have saved the world from catastrophe. So we are grateful to be in their company. Sherry Rowland came to UCI in 1964, a year before we had even opened our doors. One of a remarkable cohort of established scholars who chose to leave their campuses to come west and do something here that they could not do anywhere else. He loved this university and served it long and well, a vibrant contributor to our community for 5 decades, frequenting his laboratory long after his official retirement, and in many ways, he truly put us on the academic map. As the founding chair of the Department of Chemistry, he gave this nascent university instant credibility, able to attract other outstanding faculty, as well as postdoctoral fellows of the caliber of Mario Molina. When he and Dr. Molina investigated the issue of CFCs and published their findings in the early 1970s, they helped spur the development of a new field of scientific inquiry, the environment and Earth system science. And when 20 years later, they received the Nobel Prize in Chemistry, Sherry again helped UCI make history by becoming the first public research university to receive Nobel Prizes in 2 different fields in the same year. These first 2 Nobel Prizes and the global importance of the research into the causes of ozone loss played a significant role in UCI's election to the Association of American Universities a few months later. Sherry's legacy is alive and thriving on the campus today. Today we are one of the top universities in the nation in the field of chemistry and atmospheric science. The AIR UCI Institute brings together faculty from disciplines covering science and engineering, atmospheric admissions, chemistry, all this research aimed at mitigating impacts from health to economics to climate change. Our faculty and students in many other disciplines are leading the way in addressing the societal problems of air pollution and climate change, and our alumni in these fields hold leadership positions in regional and national government agencies, industry, universities, and non-governmental organizations. What started in a single laboratory in this building has changed the world and offers us hope for a better future. When this campus was created just a little more than 50 years ago, the dream was to create one of the great institutions of higher learning in America And the hope in the creation of any great university is that minds come together to change the world for the better. And Sherry was the one who paved the way. We are grateful to the American Chemical Society for celebrating the work done here with this recognition, and we know that the American Chemical Society is grateful for the opportunity to recognize such a special place. Thank you all so much for being here.
Through this designation, we pay tribute to the vision and dedication of Sherwood Rowland and Mario Molina and the work that they began in the 1970s. Rowland, a professor of chemistry at UCI, and Molina, his postdoctoral fellow, were studying chlorofluorocarbons. These chemicals were widely used in refrigeration, air conditioning, and aerosol spray cans. As the Royal Swedish Academy of Sciences put it in its announcement for the prize, ozone plays an exceptionally fundamental part in life on Earth. This is because ozone, together with ordinary molecular oxygen, is able to absorb the major part of the sun's ultraviolet radiation and therefore prevent this dangerous radiation from reaching Earth's surface. Without a protective ozone layer in the atmosphere, animals and plants could not exist, at least not upon land. The landmark we are designating today, with its focus on the atmosphere and the environment, is particularly meaningful to me. While at PNNL, I had the opportunity to lead the Environmental Molecular Sciences Laboratory, and during my tenure there, a partnership and long-term collaboration with scientists here at UCI has formed and established and has been something that I hope we propel into the future. But today I stand before you in a broader capacity as president of the American Chemical Society and representative of our 157,000 members. ACS is deeply committed to communicating the value of science in our everyday lives. As part of that mission, ACS created the Landmark program 25 years ago to enhance public appreciation for the contributions of the chemical sciences to modern life and to encourage a sense of pride in its practitioners. Notable landmarks around the country have previously been honored. The invention of Bakelite, the world's first synthetic plastic, Joseph Priestley's discovery of oxygen, and the invention of Polaroid instant photography. How many of you young people even know about instant photography? Right, now it's digital. California itself is home to multiple ACS landmarks, including 2 in Southern California. One at Caltech in Pasadena commemorates the development of the Beckman pH meter. The other at Scripps Institute of Oceanography in La Jolla celebrates the development of the Keeling curve, a graph that shows the rise in CO2 levels in Earth's atmosphere over time. Notice a theme there. In order to be designated as an ACS landmark, each subject must have occurred at least 25 years ago, represent a seminal achievement in the chemical sciences, and show a significant benefit to society and the chemical profession. Rowland and Molina's discovery of harmful effects of CFCs on the stratosphere ozone layer satisfies these criteria in several ways. First, their publication was published in 1974. That meets the 25-year criteria. Secondly, I would argue that the Nobel Prize in Chemistry qualifies as a seminal work. Maybe, yeah. And lastly, whether this meets the final criteria, it is clear, as the Chancellor said, that we've averted catastrophe, that it wasn't universally acknowledged until Rowland and Molina first announced the link between CFCs and the ozone danger. In fact, their announcement set off fierce debate. Ultimately, however, it led to a global environmental treaty restricting the use of a broad class of chemicals and changed the way humans viewed their impact on the Earth's environment. For these reasons, the work of Rowland and Molina and their colleagues here at UCI is a fantastic example of the transforming power of chemistry and a perfect subject to designate as a National Historic Chemical Landmark.
There are thousands of chemists and chemistry-adjacent professionals who call Orange County home, and over 1,300 of them are members of the Orange County local section of the American Chemical Society. Many of us realize, but we still take for granted, the awe-inspiring discovery that has taken place on this campus, in this building, and by chemists who now call it their professional home. The fields of atmospheric, environmental, and analytical chemistry are special to me personally, because they were fields I studied as part of my PhD work at North Carolina State University. Although I didn't get a chance to meet or work with many of the chemistry pioneers in Orange County, I felt as though I knew them through their work. Sherwood Rowland, Mario Molina, Barbara Finlayson-Pitts, Jim Pitts, Don Blake, they were important to me as a young scientist. I didn't realize it until later, but Dr. Rowland and Dr. Molina's work was one of the early environmental discoveries that inspired me to study science, to think big about our world, and to want to tell others how important it is to our lives. As a matter of fact, if my mom had come with me today, she would still tell you about the day that she remembers me running in and throwing out her deodorant and her hairspray without her knowing it. Telling her I was trying to save the ozone layer, so it was important. These scientists are fundamental contributors to a body of research that would change our world and define the very real problems ahead of us to tackle. The labs and the classrooms of Rowland Hall are indeed special to our field, not because of the scientists who have called it home, but also for the groundbreaking contributions these scientists have made to our world. On behalf of the Orange County local section of the American Chemical Society, I congratulate the University of California, Irvine and its Department of Chemistry on the dedication of Rowland Hall as a National ACS landmark.
Welcome to all. I would like to add my voice to those congratulating UC Irvine on this singular and really very unusual and important designation. I frankly did not know there was such a thing as a chemical landmark until I received the invitation to come to this event, but having read up on it, I could see why it would make a difference. The building is still the building it was. The people who did the work were the people who did the work, and they've been recognized in many ways, in many places over the years. But this is an opportunity for the university, the campus here, their colleagues, and people who work in the field today to acknowledge the importance of this work to our daily lives. And I think one of the singular achievements of the individual whose name this building is in that I need to call attention to as a policymaker is the fact that this was important science that had a connection and an effect on the planet. And we live our lives on a daily basis with the results and all of the wonderful accomplishments of scientists, engineers, and technical people in this society. And it's the basis of our foundation, the basis of our economic prosperity. But what we don't always realize is how difficult it can be to translate that work into reality in a policy world, particularly when it's controversial and when toes get stepped on, which happens whenever change has to occur. So I want to congratulate UC Irvine for being a center for that kind of disruptive effort, and to tell you how proud we in California, and all of us in the state administration, and especially the Air Resources Board, are of your work, and to be able to have benefited from it for all these years. Thank you.
So I'm honored that the ACS is bestowing this honor upon the Department of Chemistry here at UCI. This is the heritage of the legacy of Sherry Rowland and Mario Molina, and something of which I'm very proud. I'd like to take a moment to talk about Sherry, or at least as I knew him, and I think the cover of the brochure we got is perfect here. We have on the cover chemical reactions that are absolutely essential to understanding the destruction of the ozone hole. We also have two fantastic people, and it is the humanity of Sherry Rowland that is the legacy that the department holds today. When I arrived at UCI, Sherry welcomed me with open arms as a colleague, just as he had done in building up the department from the inception. I had many great conversations with Sherry in the hallway, which we shared, even though he was fantastically busy saving the world, and that was before the Nobel Prize. He always took the time to talk with me and inspire me, and this in turn has continued my relationship with my colleagues. I might add, since Ralph Cicerone unfortunately is not able to join us, terrible tragedy, Ralph did the same. That humanity percolates throughout this department. After the Nobel Prizes, Sherry continued to teach our students, our freshmen, and continued to be a source of inspiration for the next generation. And I think, again, this just says what sort of a scientist and a person he is. We continue that legacy. For those of you who were able to go to the High Impact Hire Symposium, we got to see the idea that UCI continues the legacy in atmospheric chemistry with the fantastic people we've hired. When UCI turned 50, we adopted the motto, Bright Past, Brilliant Future, and I see that in the combination of the legacy celebrated in the installation of the National Historic Chemical Landmark, and in the future as we move ahead and continue to be involved in all aspects of the environment. On those notes, I think I will pass the floor along. Thank you very much for coming here.
First of all, so we've heard about, James's words about the warmth of Sherry was absolutely critical. And as an example of that, I'm going to ask, well, this only works halfway because there's a lot of people in the back that are standing up, but I'd like all of the Rowland Group members, and we have people that are here from the 70s and the 80s and the 90s that came from Canada, they came from the Midwest. So if you would just stand up right now and be acknowledged as Rowland Group. I just want to take just a minute maybe to say that it wasn't always rosy. I mean, Mary talked a little bit about it, Allison talked a little bit about it, but I came to Irvine in 1978, and I joined the Rowland Group in 78, and so he'd already done all of his famous work, and it was downhill after that. But it was at a time when the field of atmospheric sciences was just exploding. And people like Ravi right here in the second row, pay attention, a kineticist, it was people like him and Barflace and Pitts and others who would do experiments on chemical reactions to see if A plus B goes to C and how fast it goes. And there was so much of this that was going on that almost weekly, at least every couple weeks, there was a new paper that came out that said, oh, well, this reaction, it turns out, goes twice as fast or half as fast, or this is a reaction we did not even consider when it came to trying to estimate ozone depletion. And so what happened was the 5 to 8% ozone loss that Sherry and Mario predicted, if sort of business as usual, it dropped from 8 to 4, went to 12. It was just, sometimes it went negative. And so the problem with that was that it gave industry an inroads to say, let's just wait, and we'll just wait until we have more proof of this, okay? Well, Ravi showed today that it's going to be, 150 years from now before the CFCs are at a low enough concentration that we don't have an ozone hole and that they're not such a problem for climate change. And so those years between maybe 74 and 85 were, I don't think they were good years. I think they were very hard years. Fortunately, we had Sherry Rowland, who, as Ravi pointed out, was this huge man, scary to look at, scary when he would look over his glasses at you, especially as a graduate student. But he was a person who took up the torch, and he transitioned from the science, the very good science that he and Mario did, to policy, and to where he was the spokesperson for this. And I don't know, if it had been somebody besides Sherry Rowland, I'm not so sure it would have been as effective. So this award it's a Mario and a Sherry award, but Sherry was really a force. And for those of us that worked with him, it was an absolute honor and a pleasure. I've been asked to read the speech that Sherry gave at the Nobel banquet, December 10th, 1995. Your Majesties, Your Royal Highnesses, ladies and gentlemen, my friends and colleagues, Paul Crutzen and Mario Molina and I are most grateful for the honors bestowed upon us today, for the Nobel Prize is the ultimate in recognition in the scientific world. It is immensely satisfying to us that our efforts to understand the chemistry of ozone in the atmosphere have been judged worthy of this honor. The atmosphere and its manifold changes have held fascination for men and women ever since human beings have trod the earth. Its study played an integral role in the evolution of natural philosophy from which all of our present sciences have spun. The scientific and technological developments of the past several decades, not available to our predecessors in past millennia, have provided the theories and tools which have now permitted us to develop a significant understanding of several atmospheric processes which affect the concentration of ozone in our stratosphere. This ozone is vital to us and to all other species living in the sunlit Earth because it both establishes the temperature structure of the atmosphere and simultaneously protects us against damage from the most energetic solar ultraviolet radiation. We now know that ozone is subject to transformation by long-lived chemicals, both natural and man-made, released at the Earth's surface, and substantial reduction in its concentration could have a strongly deleterious effect upon mankind and upon the rest of the biosphere. Our gratitude extends well beyond our own personal satisfaction because these honors also confer high scientific approval upon the field of atmospheric chemistry and upon environmental sciences in general. The current understanding of the atmosphere has progressed over the past 2 decades through the skillful and dedicated work of many hundreds of colleagues in the field of atmospheric chemistry. Their work has collectively evolved into the point where the nations of the world have accepted through the Montreal Protocol of the United States the need for careful monitoring and some instances control of gaseous emissions to the atmosphere. Once again, speaking on behalf of Paul Crutzen, Mario Molina, and myself, we thank you all for the wonderful honors given to us today. Thank you very much.
It's my distinct honor to recognize the discovery of the ozone-depleting effects of chlorofluorocarbons as a National Historic Chemical Landmark. Chancellor Gilman will unveil the commemorative plaque as I read the language aloud. The plaque will be installed here at UC Irvine's Rowland Hall, the same building in which Rowland and Molina undertook their revolutionary research. The plaque reads, "At the University of California, Irvine, F. Sherwood Rowland and Mario J. Molina discovered that chlorofluorocarbons, CFCs, could deplete Earth's atmospheric ozone layer, which blocks the sun's damaging ultraviolet rays. When the scientists reported their findings in 1974, CFCs were widely used as refrigerant gases and as propellants in aerosol sprays. Rowland and Molina convinced skeptical industrialists, policymakers, and the public of the dangers of CFCs. The scientists' advocacy and the discovery by other researchers that the ozone layer over the Antarctic was thinning led to worldwide phase-out of CFCs and the development of safer alternatives. For their work, Rowland and Molina shared the 1995 Nobel Prize in Chemistry with another atmospheric chemist, J. Paul Crutzen. Congratulations.
Nicely done. Thank you so much.
Okay, and I want to thank once again the American Chemical Society for reminding us what can happen when you dedicate your life to science, truth, and humanity. So without further ado, please join us for a great reception. Thank you all for coming, and once again, thank Joanne for sharing Sherry with us for so many years.